All right, so your I can statement for this is I can model the area of a rectangle with quadratic functions and solve for missing side lengths. All right, so the whole part of this lesson is using the formula for area of a rectangle to both set up equations as well as find missing side lengths. All right. So, like I said, instead of them giving you the area and one side length, they're giving you just the area, and then they're going to tell you like certain expressions that represent the other two sides. And we have to use quadratics, or the stuff that we learned back in 8.3, to find those missing side lengths. So again, the area of a rectangle, this formula, this whole lesson, you're going to live and breathe by that formula. A equals length times width. All right. So area of a rectangle, we're only focusing on area of a rectangle, no other type of areas. So just area of a rectangle, which that should be like, automatic for you guys what that formula is. Now, using the formula for the area of a rectangle, we're going to set up these problems so we can solve for the width and length of the rectangle. And we're going to use the factoring method for finding zeros. So if you don't remember what the factoring method is, you'll refer to 8.3. That was the notes that we did last week. So just to recap, if I'm solving by factoring, if I'm finding the x-intercepts by factoring, what's my first step to solve by factoring? Nope. There's one step before that. You have to get one side equal to 0. So first you got to make your equation so that one side's equal to 0 by adding or subtracting whatever you need to do. All right. Once you get one side equal to 0, then you can factor. Then once you get your two factors, what do? Guys, quit. So after we factor, what do we do with those two factors? How do we get our answer? We take those two little tiny factors and so for example, if I had x plus 2 times x minus 3 equal to 0, how do I solve that? Well, that's how we get the answer, but how do I know what my answer is? Right, we set both of these mini equations equal to 0 and solve them individually. So that's your last step. You set both of the little equations or your mini equations equal to 0, solve them individually. You should get two answers. All right. So you got to remember those steps. If you don't, look back at your notes from last week for 8.3. All right. It's very, very important that you know how to do that. So let's look at a very simple example first, or one where they actually give us a picture. So we're going to find the width, or x, so the width is x, when the rectangle has an area of 55 square feet. So looking at this picture, the width is x, so this is the width. So that means the 2x plus 1 represents the what? The length. So this here is the length. All right. Now the area of this rectangle is equal to 55 feet squared. So I'm going to set up an equation first to solve for the width. How do I do that? So what's the formula for area of a rectangle? So area is equal to length times width. Don't we have basically all the parts? You sure?
Since I'm wrong, yes.
So we do have all the parts. So what do we do?
We're done.
We plug in the values for length and width, multiply them together, set equal to our area. So we would have width times length is equal to our area, which is 55. So length times width is equal to area. Our length is 2x plus 1. Our width is x. X times 2x plus 1 gives us our area of 55. We literally just put it back into this formula. All right, that's all you had to do. Now, how do you think I'm going to solve this? What do you think my first step is? Distribute. Good. So I'll distribute the x. So I would get 2x squared plus x is equal to 55. Now, I'm solving by factoring. So what do I need to do first? Nope. We're solving by factoring, not taking a square root. Right. We got to subtract 55 to both sides to get one side equal to 0. So this goes away. Now, does 55 have anything to combine with on the left side, the equal sign? No. So we just leave it as is and we just bring down the minus 55. So this would be 2x squared plus x minus 55 equals 0. Yes, sir. Yeah. All right. Yes, ma'am. Right. So once we get to this step, there's obviously no GCF because we have this 1x in the middle. All right. So since there's no GCF, we automatically go into big X. So remind me, what goes on top of big X? A times C. What's A times C in this case? Right, 2 times negative 55. This is A, this is C. The 1 here is B. So what's 2 times negative 55? Negative what? Negative 110. What goes on the bottom? B. What's my B value? 1. So I need two numbers that multiply to give me negative 110, add to give me 1. All right. It's actually a pretty obvious factor because what number besides 1 and 2 is 110 can obviously be divided by? Let me ask you this. Any number that ends with 0 can automatically be divided by what number? 10 or 5, but I'm looking for 10. So what's 110 divided by 10? 11. So if I have a negative product, that means one of the numbers has to be negative. So is it true that 11 and 10, if one of them was negative, would add to 1? Yes. Which one has to be negative if it adds to a positive 1? 10 has to be negative. So this would be 10. This would be 11. Now, we're then going to do a quick reverse box. So I put 2x squared in the top left, negative 55 in the bottom right, and I'm using my two factors to replace the positive 1x. So I'll put 11x here, negative 10x here. Now, what are the only two values that can multiply to 2x squared? X and x and 2x. Good. So the biggest issue is we got to figure out where that 2x go. So will the 2x go on top or on the side? Why would it go on top and not the side? Right. So the 2x has to go on top because if we put it on the side, nothing times 2 that's not a fraction would give us 11. All right, we want whole numbers that would give us 11. So the x goes on this side because obviously a number times 2 will give us negative 10. And what is that number? So 2x times what gives me negative 10x? Negative 5. So that's this number. X times what gives you 11? 11. So this would be plus 11. And then to check ourselves, negative 5 times 11 is in fact negative 55. So these are my two factors. So my two factors are 2x plus 11 times x minus 5, and it's still equal to 0. So I factored it. Now I got to solve it. How do I solve it? Right. 2x plus 11 equals 0. X minus 5 equals 0. So I'll solve the x minus 5 first because that's a very simple one-step equation. Add 5 to both sides. X is equal to 5. Subtract 11 to both sides. 2x is equal to negative 11. Divide by 2. X is equal to negative 11 halves. We'll just leave it as a fraction. So these are my potential two answers. However, there can only be one width. So one of these numbers is the width. Which one do you think it is? 5. Why? Well, your width could be a fraction, but there's a big reason why negative 11 halves is not the answer. Because it's negative. Why can we not have a negative width? Think about it logically. In the real world, do you have negative measurements? No. If you look at a ruler, all right, are there negative 11 and a half inches? No. There's no way you can get a negative measurement, so that answer is automatically thrown out. Yes. You can get a negative amount of money, but not when you're like constructing something. So we're talking about area. Money, you can definitely get negative. So if like this was a problem about money, yeah, you can get a negative answer. All right. So my width in this case is 5. So this is my width. So again, make a note. Negative answers cannot work for area problems. So if you get a negative answer, which more often than not you will get at least one negative answer, that cannot work when you're talking about area. So that means my width, or W, is equal to 5. So that's my width. So one of these side lengths is equal to 5. So this side's equal to 5. Now, knowing what we know about area, what do you think the length's going to be without using the other function? If the width is 5 and the area is 55, what's the length? 2 times 5 plus 1. So that's the other way we can get it. We take, if x is equal to 5, to find the length, if the length is equal to 2x plus 5, we'll take this 5, plug it in for x, and evaluate. 2 times 5 plus 1. Yeah, that would help if I wrote the correct number. So 2 times 5 is plus 1, 11. So my length is equal to 11 feet. Guys, shh. So that's my length. Now, if I didn't know to put it back in for x, what's an obvious way I could have found it without it? Guys, what's 55 divided by 5? 11. So your length in this case is equal to 11 feet. And like I said, you want to check yourself. If you know the area is 55, if your two numbers that you get do not multiply to give you 55, you did not get them right. All right. So 11 times 5 is in fact 55. Now, we're going to do one more and then finish the rest up tomorrow because that's where I stopped my first period. So I don't want to get ahead of them. So look at the next example. So before we even touch the next example, one thing that we got to note is that oftentimes with word problems, we are not given a picture. of the scenario. So that first one, they gave us a nice picture that set it up. That's not always the case. If that happens where you don't get a picture, you got to draw one. Most of us in here are visual learners. I especially am. All right. If you're given a word problem, especially if it has something to do with geometry, draw that picture. It takes like 2 seconds. All right. Draw that picture because it will help you visualize what's going on. All right. So draw a picture like this picture here. Like just take the 2 seconds and draw that rectangle and set everything up so you know what's going on. Now, if you're one of those that can visualize in your head, that's great. But when in doubt, draw the picture. I can't always visualize it in my head. I always have to draw a picture more often than not. All right. And I have 2 degrees in math. So I'm telling you guys, drawing that pictures helps. Okay. So if you are not given a picture, you need to draw one to model the problem. All right. You want to get into the habit of that whenever you're dealing with word problems in geometry. Yes.
Is the length 15 and the width 3?
No.
Or is that other way around?
Nope.
Definitely.
All right. So we're going to consider a rectangle where the area is 45 square feet. The length is 1 less than twice the width. And we want to know the dimensions of the rectangle. So we got to find the length and the width. Now, part A is asking us if we represent the width of the rectangle as the variable W, so the width is equal to W, we want to write an expression for the length of the rectangle L in terms of W. So in other words, we want to describe the length in terms of the width. And they did tell us that in the problem. So width is equal to W. That's our variable in this case. W is the width. What did they say? How does the length relate to the width? What did they say in the problem? Guys, stop talking. Embry. Right. The length is 1 less than twice the width. That's why I highlighted that. That's how they're describing it. So, remember way back in last semester when we're turning expressions into math. So, words into math. It has the word than in it right here. So, if it says the word than, that means instead of reading left to right, you read from right to left. So, where do we start? What part of that expression? Right, twice the width. So length or L would be equal to what? If I'm saying twice the width. What does twice the width mean? Multiplied by 2. So I would represent that as what in math? So we're multiplying the width times 2. How do I write that as an expression? So if width is W and I'm multiplying by 2, what do I write? No, that's squaring it. We're just multiplying by 2. 2W. So the first part of this is 2W. The second part is 1 less. What does 1 less mean? Minus 1. So 2W minus 1. That's our expression for the length. Now I got enough to draw a quick picture. So I'm going to draw a rectangle. My width is represented by what? W. My length is 2W minus 1. And my area is equal to 45 feet squared. All right. So there's my quick picture. Now I can use that to set up an equation to find the width. So right now we're finding the width. So we're not solving for length just yet. We're just finding the width. So let's set up that equation. So how would I set it up? Very similar to what we just did in the last one. Say that one more time. I heard none of that. Right. We do W times 2W minus 1, and it'd be equal to what? 45. So that's our equation. Now we're going to solve it. So how would we solve that equation? What's the first step? Distribute. So I'm going to distribute it. So I get 2W squared minus W equals 45. What's my next step? Minus 45 to both sides because I need one side equal to 0. That goes away. I get 2W squared minus W minus 45 is equal to 0. All right. Now we're in factoring land. So what's my first step? Big X. There's no GCF, so I go right to big X. What goes on top? A times C, which is not just 90, but negative 90. So 2 times negative 45 is negative 90. What goes on the bottom? Negative 1. That's my B value. So I need two factors of 90 that add to negative 1. And since we have a negative 90, that means one of those numbers has to be negative. So one of the numbers has to be negative, the other one has to be positive. What do you think those two numbers are? 9 and 10. Good. So 10 minus 9 obviously gives us 1. Which one has to be negative if we were shooting for negative 1? The 10. So negative 10 and positive 9 would add to give us negative 1 and multiply to give us negative 90. Now we're going to do a quick reverse box. What goes in the top left corner? 2W squared. What goes in the bottom right? Negative 45. Then I'll fill in the blanks with my two factors. So negative 10W and 9W. So what are the two values that need to go in the top left corner to represent the 2W squared? W and 2W. Where does the 2W need to go? Top or bottom? Or top or side? Side. Because 2 times not a whole number gives us 9, whereas 2 times a nice whole number gives us negative 10. So the 2W goes here, W goes on top. 2W times what gives you negative 10W? Negative 5. W times what gives you 9W? Positive 9. And then to check ourselves, 9 times negative 5 is negative 45. So we know we got the right numbers. So these are my two factors. I then have 2W plus 9 times W minus 5 is equal to 0. How do I finish up solving? So set both of them equal to 0, solve them individually. So how do I solve W minus 5? What's the only thing I got to do? Add 5 to both sides. So W is equal to 5. How do I solve the other one? Subtract 9 first from both sides. 2W is equal to negative 9. Then what? Divide by 2. W is equal to negative 9/2. So, based off of those two answers, which one's my correct one? 5. Why? Right. 5's our width because we cannot have a negative number. So again, cannot have negative side length. So my width is 5. So I'm just going to write this off to the side. The width is equal to 5 what? What's my units? Units. Inches, feet, meters, yards. What is it? Feet. All right. Now I need to use that to find my length. How can I find my length? Right. My length would be the same thing as 2 times 5 minus 1. I take what I got for W, plug it back into the original expression up here. So this is my length. I have W. I just need to find the length based off of that expression. So what's 2 times 5? So what's 10 minus 1? 9. So my length is equal to 9 what? Feet. Now, is it true that if I have a rectangle with a width of 5 and a length of 9, does that give me 45? Yes, 5 times 9 is in fact 45. All right. The other two problems we'll save for tomorrow because this is where I stopped my first period, so I want to stop here today too. All right. So, yeah, I'll leave it up. Yes. Sorry, say that again, Christian. Scroll to the top. That good? Or any more? That one? Oh, it would help, but yeah. That's what you need? Okay. So, there is a